right, so what does all of this that we've been doing with inverse matrices have to do with solving systems of equations? So let's take a look at that. So we've done this already. So for a quick review, we need to know how to write a system of equations as a matrix equation, and then vice versa, how to take a matrix equation and write that as a system of equations. So here I have my matrix equation on the left and my system of equations on the right. So remember, this is just a matter of matrix multiplication. So we're going to follow that process where we would say 2 times A plus 3 times B is going to give me this value 5. So again, 2A plus 3B equals 5. And I'm going to do the same thing for the bottom one, negative 1A plus 4B equals 3. So we can see how those go together. And so moving on, remember that when we solve just a regular old equation, so a pretty simple equation up here, and we're going to solve this for x, what do we need to do? Well, we're going to need to multiply this by its reciprocal or its multiplicative inverse. Right? I would want to multiply that by 3/2 in order to undo that 2/3. Right? Which means I'd also have to multiply this by 3/2. Right? So in the end, I'm going to get x equals, well, 8 times 3/2 is going to be 12. Right, so I get x equals 12. Well, the bottom line is what I did was I multiplied each side by the multiplicative inverse, which gave me the identity 1, right? 1x. And that's what we need to do to solve this. Well, it works the same way when it comes to matrix equations. When I have a matrix equation, I'm going to multiply each side by the matrix inverse, which again is going to give me the identity matrix. So it's the same idea. In our number system, we're going to multiply by the multiplicative inverse. In a matrix equation, I'm going to multiply by the matrix inverse in order to get the identity, right? In order to get whatever I need on the left-hand side alone. So let's take a look at what this looks like. So here I have this matrix equation, and I'm going to call this A. I'm going to call the right-hand side B, and this is just my xy. Right? That's what I'm trying to find. I need to solve for x and solve for y if I'm talking about a system of equations. So here's my notation for this matrix equation. I have matrix A times my variables x, y equals matrix B. And I can write that out as a system of equations. Right? I can say now that's 3x minus 5y equals 1, and then I would have 2x plus y, 1y, equals negative 2, right? There's my system of equations, just as a quick review. Right, but this is what it looks like as a matrix equation. So how am I going to solve for x and y? Well, in order to get x and y alone over here, I need to undo this. Now recall in the last slide, in order to undo, I needed to multiply by my multiplicative inverse. When we're talking about matrices, I would multiply by my matrix inverse. So if I multiply by inverse matrix A, I would be undoing essentially this matrix here. But if I multiply that side, then I'm also going to have to multiply this side by inverse matrix A. Right? So I would undo this by multiplying by inverse matrix A. So essentially, in order to solve for x and y, I'm just taking matrix B and multiplying it by inverse matrix A. That's going to give me x and y alone. So let's take a look at an example. Right? Oh, I'm sorry, one last thing here before we look at our example. So this is what this is going to look like. I have matrix A. I'm going to multiply by inverse matrix A to undo, which means I need to multiply the other side by inverse matrix A as well. So to solve for a system of equations in matrix form, I need to multiply both sides by inverse matrix A. Now the shortcut would be to say, well, just multiply the right-hand side by inverse matrix A, because I know that that's going to undo itself over on the left. Right, now for an example. All right, so I have this system of equations right here. And I went ahead and I wrote that as a matrix equation. Right? So 3x negative 5y gives me 1. 2x plus 1y is going to give me negative 2. So that matches my system of equations over here. So remember what we said. We want to multiply both sides by inverse matrix A in order to undo this and to get x and y alone. Right? So I need to multiply my right-hand side by inverse matrix A. Now be careful. The order is going to matter here, right? The order in which we multiply matrices does matter. It's not commutative unless we're multiplying a matrix by its inverse. Otherwise, it's not going to be commutative. So I am multiplying both sides by inverse matrix A in order to get x and y alone. So here's matrix A. Go ahead and use your calculator to find the inverse of matrix A. So let's pause for a moment and find your inverse of matrix A. So hopefully you used your calculator. You found the inverse of matrix A, which is going to be this matrix that you see here. So remember, what do we want to do? We want to multiply matrix B by the inverse of matrix A, which is what we just found. So I want to multiply this matrix B right here by the inverse that we found. And again, order does matter, so I'm going to rewrite that over here. So I need to multiply inverse matrix A. It's my 2 by 2. It's going to look a little messy, sorry about that. Bottom line is what I want is matrix A first and 3/13. And I want to multiply that by matrix B. And that's going to give me x and y alone, which again is what I need. All right? So now that I've multiplied it in the correct order, I have the same number of columns in my first as number of rows in the second, which is why I need to multiply in that order. Again, so I want you to pause and go ahead and use your calculator to multiply those two matrices. If you don't know how to multiply your matrices on your calculator, you're just going to go to you're going to edit your matrices. You're going to hit matrix A times matrix B, enter, there you go. Right? So again, pause for a second. Go ahead and multiply those. If you don't want to do it on your calculator, that's okay, do it by hand. But we should be getting, after you pause and do this on your own, you should be getting these values. So when you multiply matrix B by inverse matrix A, you're going to have negative 9/13, which is your x, and you're going to have negative 8/13, which is your y. So as a quick summary right here, to solve a system of equations with matrices, we're going to first find the inverse of matrix A. We're going to multiply that by matrix B, which is going to give us x and y alone.